Let's move on to part 2 of the assignment, which is dealing with detecting outliers. We're going to use the same data set that we used before. We have 30 participants and we have 4 different psychological measures. So one way to detect outliers is through a visual inspection of a histogram. So we're going to look up at the histograms we made in part 1 and determine whether there appear to be any unusual cases. Okay, so we're going to explain our findings. Let's go ahead and look up here and see if anything looks unusual. So go up here. Well, this doesn't appear to be anything hanging off to the side there. Depression, these guys kind of are on their own, but if you look at it, it seems like it's just part of this tail, just part of this skew. Self-esteem, there is a very conspicuous case. So everyone else is over here doing their own thing, and this guy is way over here on the side. So there looks like there may be an outlier right here. Again, with agreeableness, anything that's strung out here just looks like it's part of the skew. So it seems that in the self-esteem variable, there's one outlier that is a higher value. So this is a higher value, a value that's significantly higher than, substantially higher than the rest of the observations. Let's say something about that. So we could say that there is one apparent outlier in the self-esteem variable, which appears to be much higher than the rest of the distribution. So it's a very informal way of assessing for outliers. We just take a look and say, hey, that looks like an outlier. But in a situation like this, it's a lot tougher. How do you decide if that's an outlier? It doesn't seem to be, but that's why we have other ways of assessing, right? So let's go back down here. Using the same data set as before, right there, generate box plots of all 4 variables and paste these figures below. Okay, so how do we do that? We go over to graphs, chart builder, and we don't want histograms anymore. We want box plots. We click box plot down here, drag this guy up to the window. We'll have to do these one at a time. So we'll grab anxiety and drop them here. I'll try that again. Oh, on the left here, much better. You would only use a variable on the x-axis if it were a categorical variable, if we were trying to compare anxiety between males and females or something like that. So I should have put this over on the left to begin with. So we're just, there'll be nothing here. We're just looking at the entire anxiety distribution. So anxiety goes here, click OK, and there is our box plot. So go ahead and we'll grab that guy, copy special, and we'll drop it down here. And we'll have to make them smaller. There we go. And there's really not room to fit them all here, so I'm just going to bring this down to the next page, and we'll put them all down here so they can fit. We can look at them together. Okay, so we'll have to do wrap text square to position it. Make some more room here. Okay, so graphs. Let's move on to depression. Depression goes here. There we go. Ooh, interesting. Okay, so copy special, and we'll drop him here. And make it smaller, wrap text square, and put him right there. Make it just slightly bigger so they're the same size, so they look nice together. So anxiety, depression, we need self-esteem. Okay, ooh, very interesting. So grab this one, copy special. Ooh, messed up, copy special. Drop him there, resize it, wrap text square, and we'll try to make that close to the same size as we can. And there we go. Right about there. And then we'll do our last graph, which is of agreeableness. And here we go. So we'll go ahead, copy special, and we'll drop our agreeableness variable right here. Okay, wrap text and square. Okay, that looks just about right. Okay, so box plot is another way of assessing for outliers. So when the computer generates a box plot, it has its own formula for determining what is indicated as an outlier. And the circles and stars, the asterisks, those are signifying what it considers to be outliers. The numbers next to these circles and stars, these aren't the values of that observation, it's the number of the observation. So what I mean by that is, let's take a look here. Right down here, where it has the 30, that's talking about participant number 30. And this is on the agreeableness variable. This person has a score of 0.32. and that's much lower than everyone else. So if you were trying to find this in your data set, this is the number you'd use. You go down number 30 and find it. If I sorted the data and reorganized it, these numbers would change. So if I were to organize it by self-esteem, and now this were observation 25, this would change to 25. So that's what those little numbers mean. Anyway, we don't need paste SPSS here. We already did that. So inspect these box plots. Do there appear to be any outliers? Explain your findings. Well, the anxiety variable looks like it's very normally distributed, right? So the median's right here in the middle, and there are no observations poking out either side. It looks pretty even. And you can see the skew here. You can see the skew in the, what is that, depression variable and the agreeableness variable, the positive skew and then the negative skew down here. It looks like there may be one outlier at the high end of the depression variable, one outlier at the high end of the self-esteem variable, and then 3 possible outliers at the low end of the agreeableness variable. So there do not appear to be any outliers, there we go, in the anxiety variable distribution. There appears to be one outlier at the high end of the depression variable, another at the high end of the self-esteem variable, and 3 at the low end of the agreeableness variable. Okay, so already we looked at the histograms and we thought, well, that looks might be something there. I'm not sure about these. I'm not sure about those. Well, now we've looked at the box plots and it seems like, okay, there's the one we already saw. There may be something here and then there may be some down there. Okay. So what else can we do? Standardize all 4 of the variables with a mean of 0 and a standard deviation of 1. These are just z-scores. Sort the cases for each variable and look at the extreme ends of the distribution. Are there any observations with z-scores with absolute values greater than 3? And then how will we explain this? Okay. So we need to standardize these. So the way we do that is I have to pull up my data view, and I'm going to go to Analyze, Descriptive Statistics, Descriptives, and all I have to do is click this button right here that says Save Standardized Values as Variables. So I click on that. These are already selected, and when I click OK, it is going to generate the same statistics that I've seen before, but it's going to create 4 new variables right here. So we had anxiety, depression, and so forth. Now we have Z anxiety, Z depression, Z self-esteem, and Z agreeable. And these are the Z-scores of each of these variables. So they mean the same thing, but now they're standardized. So over here, you can see the actual values. They're centered around 0, and they go up and down from there. We no longer have the same scale. So these are Z-scores, standardized scores of all of these variables. Now, there are only 30 observations, and you could really eyeball this and just look for 1s over 3. But I do want to show you how to sort them, because if you were using a large data set, let's say you had 10,000 observations, you don't want to try to skim through all those different people, or even a couple hundred. So what you do is you go to Data and Sort Cases, and then we're going to go, it would actually do the same thing whether we use the original or the z-score, but I'll go off the z-score. And we're going to sort by anxiety in ascending order, and we'll click OK. And now they're all in order. So the one with the lowest z-scores at the top, negative 1.69, the highest at the bottom, 1.73, so the absolute values. So neither of these go beyond 3. So there's nothing beyond negative 3, nothing beyond positive 3. So based on that criteria of being less than 3, there are no outliers in the anxiety distribution. Okay, so again, this is arbitrary. I just decided it's going to be greater than 3, but someone else could have said 2 or 2.5. So just keep that in mind. So let's say that there are no observations within the anxiety distribution with z-scores beyond 3. Okay, let's look at the depression variable. So we'll go up here, we'll do data, stored cases, depression. Now let's look at those. For some reason it wants to pop up every time we do anything. It's a little obnoxious. Okay, so we have a negative 0.98. That's as low as it goes. And as high as it goes is 2.7. So that's pretty high. But we said 3, and it doesn't pass 3 even though it gets close. So based on our criteria right here, we would not say there were any outliers. There were also no outliers with z-scores beyond 3 within the depression variable. Okay, what about self-esteem? So we'll data, sort cases, self-esteem. All right, that's in the way again. So the lowest is negative 1.6, we're fine. And then, oh, look at that, 3.23. So there is a value in the self-esteem distribution beyond 3 with an absolute value greater than 3. So that's an issue. Okay, within the self-esteem variable distribution, there is one observation with make that italics, z-score, with a z-score with an absolute value greater than 3. Okay, what about the agreeableness variable? So data, sort cases, agreeableness, and ooh, this is really close, a negative 2.988, so that would round to negative 2.99, but it's not at 3, and we said 3, so it doesn't count. And then the highest is 1. So even though it's really close, this is why you have to be clear on what the rules are. We said 3, it's not greater than 3. There were no observations within the agreeableness distribution with values beyond, with z-scores beyond 3. Okay, although one came really close, didn't it? Okay, so now the instructions say to delete any observations with absolute values greater than 3. Okay, so we've got 1. Where'd he go? He's right there. So it says hence there should only be 1. Okay, we found it. We're going to rerun the test of normality for this distribution and paste that below. And we're going to see what happens if there's any changes. So to delete just this value, we just click on it and hit the delete button, and it's gone. So that little period, that's how SPSS indicates a missing value. So that means we don't know what it is anymore, and every test that we run, it's going to now be absent. I could also delete, that's the z-score, I could also delete it over here, right there, 18. So I deleted that. So now that value has been deleted, and it'll be treated as a missing value. So we're going to rerun our the test that we did above, and we'll see what that looks like. Okay, to save time because the video was running out, I went ahead and repeated all 4 of these tests after deleting that value. So we can see now that the histogram, before we saw this little piece, it looked really tight and there's this piece hanging out over here. With that one deleted, we can see that it appears to be much more bell-shaped. Looking at the PP plot, these values are very, very close to the line, whereas up here, they were close, but they strayed just a little bit, so it looks a little more normal, a little tighter. Before, the self-esteem variable was skewed, and in this case it was leptokurtic, both of these at significant levels, twice the standard error. Now, they're both non-significant. They're both below 1, so these no longer indicate any problems here. And then while these 2 tests before said that it was normal, this one was really close. It was close to being not normal, and so now it's nowhere near that. So removing the outlier definitely improved the shape of the distribution. The histogram looks like a normal curve. On the PP plot, the values are very close to the diagonal. These statistics are no longer above 1, and this value is way above 0.05, so far from significant, meaning a very normal distribution.